Welcome to the video on significant digits. Significant digits are used when you're taking a measurement. So if you were to use a metric ruler, and you've done that, some of you already, when you take the length, you're going to use the metric ruler and it'll definitely give you two numbers. It'll usually give you something in the ones place and something in the tens place, and then you have to estimate in between the lines and come up with the third significant digit. The word significant means important, and this is important as well as not as much as how much you have, but how precise the instrument is. So when you're taking the measurement, you know how many of the digits are significant because you're the one using the instrument. But in the book, when they give you problems to do, that's not going to be the case. So we have to have a series of rules that tell us how we can tell how many of those digits are significant. So the first thing we're going to do is follow those rules and just look at a measurement that has already been taken for us, follow the rules, and come up with the number of significant digits. The second part of the video will be how to perform math operations and the rules for rounding when you finally do get your answer. So I have here 4 different measurements that were made by somebody else. So I don't know how many significant digits there are, so I have to follow the rules. So the first rule says that if a number is not a 0, it's significant. So if I look at 4,507.0020, the 4, the 5, the 7, and the 2 are not 0, so they must be significant. Some piece of instrumentation has given us those numbers, so those are significant. All of the rest of the rules have to do with zeros. So if a 0 is in between significant digits, no matter how many zeros they are also significant. So there's 1 0 here between the 5 and the 7, so that's significant. And then there are 2 zeros here, and those are significant as well because they're between the 7 and the 2. It doesn't matter how many zeros are in between, if they're in between, they count. The third rule says that if a 0 only holds place value, it's not significant. That's not the case here. We don't have a 0 like that. The last rule says that if the 0 is to the right of the decimal at the end of the number, it is significant. The other way that you can tell that this is a significant digit, if you take that 0 away and you still have the same amount. So if I take that 0 away, I still have 4,507.002. This 0 is put there on purpose. This means that it wasn't rounded from 19 or down from 21, that it actually hit a line and was on 0. So this has 1, 2, 3, 4, 5, 6, 7, 8 significant digits. Every time you look at a new measurement, you're going to follow those same set of rules. So if we look at the next one, the 1, the 7, and the 3 are significant because they're not 0. There aren't any zeros between digits, so we don't have to worry about that rule. The third rule says that if a 0 only holds place value, it's not significant for measurement. So that's what these 2 zeros are doing. The only purpose of these 2 zeros is to keep that decimal there and start this 1 in the thousands place. So these are not significant digits. If this were a stopwatch, maybe that's what this is, the stopwatch didn't start measuring until the thousands place. These zeros are only holding place value, so that has 3 significant digits. If we go to the next one, 400, the 4 is not a 0, so therefore it's significant. And then we really have to think about this. Those zeros are not between other significant digits. They're only holding place value. They're making this be 400 instead of 40 or 4. So they're only holding place value. Chances are this was 397 meters or 407 meters, and we rounded it to something, and so that's how we get the 400 or the 400 meters, and that's just 1 significant digit. So that's how you do it for regular numbers. If you have scientific notation, you follow the same rules, but you just follow it for the first factor. These are just a bunch of zeros holding place value anyway. So we follow the same rules, the 3 and the 2, and then to the right of the decimal at the end of the number, this one has 3 significant digits. And that's how you figure out the number of significant digits. And this is important so that you can do the next part, which is actual math operations with significant digits. There are 2 sets of rules. There's one set of rules for multiplication and division. There's a second set of rules for addition and subtraction. Most of the time in physics and chemistry, we're going to be multiplying and following this set of rules. But every once in a while, we're adding things together and we're going to follow this set of rules. The first thing you do is you just do the math. So you get your calculator and you have 2.608. You multiply it by 2.4. And my calculator gives me an answer of 6.2592. 6.2592. That's too many significant digits. Whatever I did measurement-wise was not this precise. So I need to figure out how can I round my answer. I look at the two things that I multiplied together and I see how many significant digits each one has. This has 4 significant digits, the 2, the 6, and the 8, and then the 0 in between. So this has 4. And then this only has 2. 2.4 has 2 significant digits. So when I multiply and divide, I round to the smallest number of significant digits. So I need my answer to only have 2 significant digits, not to lose value or change the value, just change how precise it is. So I can keep something here and I can keep something here. Well, 5 changes the 2, and this is going to be 6.3, and that would be centimeters squared. 2 significant digits, because the one thing that I multiplied by, I only had 2 significant digits. You do that for multiplication and for division. You round to the smallest number of significant digits. Addition and subtraction is different. The first part is the same. You do the math, 1.701 plus 3.2 plus 1.67, and I get 6.571, and that would be meters. When you add or subtract, you look at the place value that each individual measurement is precise to. So this is precise to the thousandths place, this is precise to the tenths place, and this is precise to the hundredths place. So this is not the best instrument for the job, it's the worst one, and this is the best one. You have to round to the worst instrument that you use, which is the lowest place value. So that would be the tenths place. So that means I can come down here to my answer. Here's the tenths place in my answer. That means I have to round to that tenths place, and this is going to be 6.6 meters. And those are the rules for addition and subtraction, the rules for multiplication and division.